universe is delivering to us right now. So we'll see what happens with the James Webb Space Telescope, which is what I'm really excited about for the future. So James Webb, as I mentioned, was launched Christmas Day, last Christmas, and it's about to release its first science observations a week Tuesday. So I think you'll want to stay tuned for this. I think it's going to be pretty exciting. This is a telescope. It's a 6.5 meter telescope. Hubble's a 2.5 meter telescope. It has 18 mirrors. These are made of beryllium and coated with gold. This telescope, I first heard about 25 years ago. I was on a scientific advisory committee that had been charged with coming up with what would succeed the Hubble Space Telescope. So this was the idea. And a few astronomers were asked to go to the Goddard Space Flight Center. We were giving some advice, scientific advice, and we first heard about this telescope that would have to unfold its mirrors in space. It was going to fly 1 million miles away, 1 million miles from the Earth, unlike Hubble, can't be serviced. It would have a sunshade here that would have to unfurl in space. These things, each of the 5 layers of this sun shield is about a width of a human hair, has to unfurl in space and then be locked into place. And the astronomers in the room looked at each other and said, "This is insane. It will never work." And it worked. Yeah, it's amazing. It was a picture perfect launch. It could not have gone more flawlessly. And I think they said there was something like 100 single point failures. We were literally waiting with bated breath for each one of these things to unfurl. But it made it. It's 1 million miles away now. So here is, here's the moon. This is Hubble's orbit. Hubble's in a low Earth orbit, but well, here, 400,000 kilometers above the Earth. And this, the James Webb Space Telescope is now about 1 million miles from Earth. And it's a place called the L2 Lagrangian point. I'm not going to ask you about that later either. But the first images, they took of a star. There are 18 of them here that just happens to magically match the number of mirrors there are. So it was actually one star, but it was all over the place. They had to spend weeks fine-tuning the positions of the mirrors so they knew where each of these stars should go. And eventually they were able to focus it into a single image. And that image, or the calibration image, turned out to have galaxies in it that had never been seen before. So even the test images now are proving to be just spectacular. Here's an image that was taken by the Spitzer telescope at the 24-inch telescope in space, a mid-infrared telescope. Here was, again, this is a test image from Webb and the mid-infrared instrument taken in May. Now, why is Webb so interesting? Why do we want to observe in the infrared? Here's a picture. This is the Eagle Nebula. It's a region in the Milky Way where it's essentially a stellar nursery. New stars are being born in these pillars here. They're, I think the number is something like 6 trillion miles high, these things. And that's small by astronomical standards. This is a small region in our own Milky Way galaxy. And you can see these dark patches here. We can't see any stars in this nursery. But when we observe in near infrared light, suddenly you can start peering through the dust and you can start seeing where there are stars that just are not visible in optical wavelengths. And then in the mid-infrared, when you go to even longer wavelengths, you start seeing the dust radiating itself, and you can learn about the dust properties. So it has this incredible capacity. Also, because the universe is expanding with time, as we look farther and farther back, we're seeing earlier in the universe, as the universe was when the light left those objects, because light travels at a finite speed. That's something that Albert Einstein taught us. And because of the expansion, the wavelength of light is being stretched and it's being shifted to the red. And so we can observe farther back in time.
Well, hello everybody. It's Scott Roberts, Annie Scarborough, And we are here for Explore Alliance Live. And so
It's
what you were
definitely
hearing,
live.
what's that?
It's definitely live.
It's definitely live. That's right.
And we know,
What you were
and we know
hearing at
Scott's
the,
coffee is hot.
it's
I was
hot.
saying, and we know your coffee is hot.
That's right. So we were listening to a little piece of the presentation from Dr. Wendy Freedman. She's, an astronomer, cosmologist type of astronomer from University of Chicago. And her defining work has been on something called the Hubble constant. Now, this is something that Edwin Hubble came up with as kind of a yardstick of measuring a mathematical measuring tool to measure the size of the universe. Since he came up with it, it's been refined, and the numbers been uh, uh, refined by measuring what they call standard candles. Okay, so those are certain types of stars, certain ways of measuring brightness or energy from the universe, and then trying to statistically remove noise out of it to get closer and closer to a theoretical model. Okay. Wendy Freedman and her colleagues, I think they have it down to a certainty of like 1%. Okay, and they are looking to refine it even further. So it was real exciting for us to be at the Mount Wilson Observatory during a time, a historic first, where the George Ellery Hale family, the extended family, um, was able to get together to finally meet one another, maybe for the very first time in their lives, and to talk about the legacy and importance of George Ellery Hale, who died in 1938, I think. Lived a relatively short life, only 50 some odd years. But in those years, he built four of the world's largest telescopes in succession. He developed the entire field of astrophysics. He developed a journal called the Astrophysical Journal, which is still published today. Um, he created the American Astronomical Society, which is what all the professional astronomers belong to today. And recently, some new developments where they're encouraging amateur astronomers to join the American Astronomical Society. In his spare time, he helped build out the city of Pasadena, helped Henry Huntington develop the Huntington Library, which is an incredible 130-acre estate and amazing archive of science books and all kinds of books. Um, and he also developed the California Institute of Technology, otherwise known as Caltech. And so, a very busy guy, didn't really have a lot of other time on his hands to get his family together like they did over this last weekend. We were invited to give or to set up and broadcast live the event. So if you had a chance to watch it live over last weekend, you got to chat and see some of this activity as Ed Krupp from Griffith Park Observatory gave a special talk. Sam Hale, the grandson of George Ellery Hale, gave some inspiring talks, and the president of the California Institute of Technology was there on hand as well. And then the second day, they went to Mount Wilson Observatory, listened to Dr. Wendy Freedman talk about the Hubble constant, which was developed at Mount Wilson, and to talk about her work on the James Webb Space Telescope. She'll be one of the very first observers to use that instrument, and so it was a real honor. We got to see her talk, got to have dinner with her. It was just really, really cool. And then they went off and looked through the historic 100-inch telescope where the some of the measurements for the Hubble constant were worked out. So, but Annie, you've been studying the James Webb Space Telescope recently.
Yeah, just in the last week, I and am new to the education world, and so I'm in the middle of a speech class, and I had wanted I had to pick my own topic. And when I was going through the TED Talks that really caught my attention, I was, because we're going to explore scientific. So that's kind of, it's like, oh wait, there's a telescope. We're talking about a telescope. Let's read that. And so let's watch that. And so I was really, really amazed. And in fact, I was telling Tyler about it today, and he goes, "Where have you been, Annie?" Sorry, under a rock. So, but it just really inspired me to think there is so much more out there, and especially whenever the gentleman that was talking, he was talking about new planets and how they're going to be able to see new planets and discover those and things like that. And so it's going to open up exploration really, really big. So it's exciting. It's exciting.
Hubble Space Telescope did that for us in it's been up there for like 3 decades now, 32 years, I think it's been up there collecting data, still working today. But Jay West will be another, just will leapfrog over what Hubble Space Telescope did for us. And so we're going to get to see the universe in a whole new light, amateur astronomers, Annie, a lot of the astrophotographers compare their 60-hour, 100-hour-long exposures or whatever to the Hubble Space Telescope. That's kind of their benchmark.
Oh,
you're about to get a new benchmark. Okay, with and the problem, a hurdle for them also will be is that Jay West images in the infrared, and you and I were talking about it earlier today, and you were talking about the gold that's on the mirror and mirrors, and that's gold reflects more infrared. It's higher performance in infrared.
Yeah. Well, that's really, and it's really neat how because I know as we were talking today, I was, you said they started this journey in 96, I think you said. They started this whole thing in 96. It's 96. And so it's just crazy to think about how far technology has come and how much further it's probably going to come even more. And so, the things that they've had to overcome and had to think about and achieve in order to even be able to get it into space is absolutely amazing. So I think what was the lady's name that was speaking? I'm sorry, Scott, but we just watched the video on
Wendy Freedman.
Okay, so did she say that was as thin as hair? Is that what she said in her talk? That
it was atoms thick. She might have described it like that, but it is very, very. That's optical coatings, including the coatings that are on our telescopes, are they're the way that they're applied is they put the polished optic into a vacuum chamber. Okay, they pump out all the air. Okay, then they have a way of driving or vaporizing the materials that they want to use. In the case of Jay West, they use gold. Okay, so they had gold pieces in there. They had an ion gun flowing an ion plasma onto the gold. Okay, now it's in a vacuum chamber, so it's making this cloud of gold that's covering everything, including the optics. Okay,
that's crazy.
So it's very, very, very thin. They usually put an overcoat to protect the coating. In the case of Jay West, I'm not sure if they had to do that or not, because there is no air in space to oxidize the coatings. And gold doesn't really oxidize anyways, not like aluminum will, for example.
Yeah. So did they? So then they mainly chose gold because of the oxidization. I can't even say it.
No, they chose gold because of the infrared reflectivity.
That's right.
Infrared, because it's an infrared telescope.
Yeah. So I didn't know if it was because of both of those things. Like I know silver probably doesn't do as well as gold, but I didn't know if maybe it just sounds like this sounds like a material that is more durable and will achieve the things that they're needing. So, but it was, as we were talking today, the other cool thing was to think about how strong it is. I think you said that you could see the details of a penny 24 miles away, and then
Right.
and then whenever we started. And whenever we started talking about it, then we started talking about, okay, well, how far can we see in a horizon? And you said like 3 miles is as far, if we're at sea level.
It's 2.9 miles or something,
It's
so
like nothing.
I'm not even 6 feet tall. I'm like 5'10". Okay. So I can't quite see 3 miles out. Okay. Even on a crystal clear day, looking out over the ocean at sea level, I'm only going to be able to see 3 miles out. You get some elevation though. Now you can start to see much further out, and many, hock climbers and stuff like that, or if you've been to the top of a mountain, you might be able to see 100 miles out. Okay. But imagine holding a penny out, somebody's 24 miles away.
You can see that. That's crazy.
What's the date on this penny here? Okay. That's what Jay West can do. Okay. So.
I mean, and when it's in our hands, we have to like bring it up so cose to our eyes just to see it.
Right. I'm using a magnifying glass, right? That's right. So
that is so crazy.
Super, right.
Yeah.
So
it's interesting. I think somebody on the chat is asking about what we think about civilization out there, and so that's a great question. I mean, there's so many different kinds of things that could be living and growing that we don't, you just never know.
One of the big problems I think humans have is that we separate everything, right? We separate everything. You're separating the whites from the colors and putting in the washing machine. You're separating, which side of the road you're driving on. You're separating which ring you put your finger. You put your ring. We separate everything, okay? And therefore, we think that we're home base, okay, and everything out there is separate from us. Okay, so when you ask the question, are there civilizations out there? We happen to be part of the out there. Okay,
that's true. That is a true statement.
Absolutely connected to everything else in the universe. So if you want to ask, is there life out there in the universe? Your first answer is yes. Okay, because we're here. Okay, it's self-evident. All right, that we're already here. Now, is there other planets out there that have life on them? Probably. Okay, probably, because it happened here. Okay, and so I think one of the big fallacies that humans keep falling into is that we think that we somehow occupy a special place in the universe. It started with us thinking, in Ptolemy's time, okay, that we were the center of the universe. Earth was the center of the universe, and everything went around us, okay? And up until really the turn, when the 1900s are getting established, Harlow Shapley is at Mount Wilson using the 60-inch telescope, measuring globular star clusters. Have you ever seen? Have you seen globular star clusters with your telescope?
Not with my telescope. No, I have not.
Yet. Okay. Well, when you do, you're going to be blown away. They look like snowballs of stars. They're beautiful.
Oh, I had to wipe mine down because I was seeing globular clusters. Once I got rid of that, I was fine.
You was fine. Okay. Globular star clusters are some of the most beautiful objects in the sky, and they can be seen even with small telescopes. There's some real bright ones out there, okay? But they look like snowballs of stars, okay? M13 is like a really famous one, the Hercules cluster, okay? Well, these globular star clusters are formed around the center of our galaxy, like in a halo, okay? And so Harlow Shapley started making very careful measurements of these globular star clusters and measuring the distances to them, okay? Probably using the standard candle method, of how he's measuring how bright these stars are, okay? Oh, these are a lot fainter, therefore they must be a lot further away, okay? And so he learned after his measurements that, oops, not even the sun occupies the center of the universe. Up until that time, general accepted reality, as we want to call it, okay, was that the sun was in the center of the universe. Wrong. We're not even in a special part of the Milky Way, okay? And then we discovered, oh, well, the Milky Way must be the center of the universe. Wrong again, okay? No, it's not. It's just one of billions or trillions of galaxies out there. So we do not occupy a special place in the universe, okay? Therefore, it's easy to infer that life is not as miraculous as it is, and how, you know, that we think it's uncommon, okay?
Yeah.
We think it's uncommon. And some people, some theorists, you know, or people putting forward hypotheses that that this is the only place where life existed, because we have not yet really detected, you know, irrefutable, hardcore proof. Now, we're not like, you know, with on the Tonight Show with an alien. Okay, we're not. I mean, it would be really cool if we were, but that hasn't happened yet. Okay, to our knowledge.
And I think.
So
I
maybe
think that
might have been an alien, but you know, so.
You never know. I think that one of the things too is, though, as we wrap our minds around life out there looking like us, and it doesn't. Sometimes it could be a small thing, microscopic living thing that's out there that we don't know about. You know,
COVID. Yeah, I would say that COVID is a living thing. Okay, out there.
Yeah,
it's a virus. Okay.
Yeah,
it collectively has a kind of intelligence. Okay, it certainly kicked our butt, you know, and right. So and things like viruses can actually survive the environs of the vacuum of space, you know.
Yeah,
and they're not the only things. All right, so there's you know, the possibly bacteria that had been blown out of our atmosphere by big asteroid impacts, for example, could have, with the solar wind, kept blowing out till some of it collected, rained down on Mars, you know. So there's an idea that you know, the genesis of life here, as amazing that you know, kind of creation event is, you know, may not be that unusual in the universe. All right. So we, you know, as far as being very technical, you know, humans are still not super ultra technical. You know, I would say they just found, I don't know if you saw this, but they just found some human remains that are now dating 1 million years earlier than the oldest human remains ever found.
Wow.
So it puts humans back to about 3.5 million years. All right, well, let's just take the last 50,000 years. How much did we technically really know? Not much, okay? Then you keep compressing it to, you know, maybe the last 500 years. 500 years, it started getting pretty interesting. The last 400 some odd years, we got the telescope, okay? So, and now today, you know, we go all the way from Galileo's kind of not very great telescope to the James Webb Space Telescope, you know?
Yeah, they were 300,000 years old, according to the carbon dating.
You're talking about these remains?
Yeah, the remains.
Oh.
3 million.
Huh?
He said 300,000.
What's the byline on this? What date is this?
Yeah.
That's why I got to 2017.
Go a little further. Right. Well, you know, if you honestly think about it, and like when she showed the Eagle's Nest nebula, and she called it a nursery of creating stars. If you think of everything in that aspect, then you have to come to the conclusion that there must be life somewhere. I mean, that's being created. Life's always being created here.
Right,
I mean, there's you can't just assume that this is the only planet that has life on it. I mean, it's, you know, so it's just, I don't know. It's really interesting to talk about.
We can't say for certain that it is. We can't. Also, you can't say that it's not. Okay, so that's the deal on that. Most people who study science, follow this kind of stuff, do realize the distances involved. Okay,
Uh-huh.
we are, light years away from other stars, and um, so that's the deal. It is very intriguing to think about. If you went to Pekka and Connor and you guys that are really kind of commenting on this, the if you went to the Jet Propulsion Laboratory and you asked the scientists there, okay, what is it that we're studying now? I mean, we kind of went through an era in astronomy where we were making maps. Okay, we were saying, okay, plotting this, and there, voila, we got a constellation. Okay, then
Mm-hmm.
we started trying to refine the positions of the stars. Okay,
Mm-hmm.
then we learned how to measure the stars. Okay, the distance to the close stars, and then we started measuring, and then this expansion thing of which started really and got kicked off big time
Mm-hmm.
in 1923 when Edwin Hubble discovered a variable star in the Andromeda Nebula. Okay, that happened at the 100 inch at Mount Wilson, and
Mm-hmm.
suddenly we went from, oh my goodness, the whole universe isn't just the Milky Way. There are lots and lots of these other
It's a
island
lot of stuff out there.
universes. Yeah,
Yeah.
and so that went from, I don't know, probably thinking initially there's a few hundred of them to a few million of them to a few billion of them, and now maybe it's a trillion, and maybe there's parallel universes. So
Yeah, you just
that is
there's no
the
count.
deal.
I don't think we can count how many things are probably out there. Out there, it just keeps going and going and going, which is amazing. I mean, what a great exploration, to be able to be a part of and and
Sure.
watch that a journey unfold. I mean, I know that they had major things to overcome, from getting the telescope into the rocket to getting it out into space and unfolding it, and there was just a lot to
Incredible.
do in order
Yeah.
it to be able to do that. And so, and I want to know who thought. Okay, I just can see them trying to figure out. Oh, this telescope is way too big to fit in a rocket. Let's figure out how to origami fold it down so it'll fit in there.
It was an origami, and it was amazing. I mean, I think Wendy said in the talk there was like 100 points of failure. There was more than 100 single points of failure. I think it was like 300 and some odd. Just crazy. Okay. Numbers of likelihood of failure on this instrument.
Mm-hmm.
But the point I was making about the Jet Propulsion Laboratory, if you went to the Jet Propulsion Laboratory today and asked them how are they studying, what is it that they're really after to study in the universe, it's not
Mm-hmm.
distance, it's not the spectral analysis so much, okay?
Yeah.
What they're searching for is life, okay? And they're
Yeah,
very
that's really what
serious about it, okay? So,
Yeah. Well, that's why they're constantly looking for new planets. I mean, the first time I read about, I think Jerry Hubble, I read an article on Jerry Hubble, him figuring out. I can't remember what kind of planets they are, but because of the way they pass, the light that comes, like you could just see the shadow of it, and so that's how I can't remember what they're called.
That's how amateur astronomers can see
Yeah.
exoplanets. There's
Yeah.
methods. They're measuring the brightness of a star. They
Mhm.
predict. There's a prediction of the exoplanet. They get these
Yeah.
predictions, and so professional and amateur astronomers actually go and study it and see. Oh wow, does this light curve dip? Okay, match what was predicted. Okay, if it does.
Yeah.
Then you probably got to, that adds strength and weight to,
Yeah.
That's a planet. So,
Yeah. Yeah, and that's really neat to think about. I mean, as hope this telescope will probably help with some more of that study and be able to find more planets out there. And yes, of course, that's what we're looking for is another life, a life out there. Are we the only ones? Which
right.
On this planet, we aren't the only ones. We have so many animals and other things here that it's you can't say.
Right. Yeah. So hopefully someday, Annie, you can go and visit the Jet Propulsion Laboratory. It's a wonderful place. I'm an ambassador, volunteer ambassador for NASA and JPL, and
Okay.
I've been for many years. And it is just, it's amazing. And the scientists that work there, they'll tell you, they'll say, look, this is a special place. They say that animals come up to them. They talk about it in ways that
they just walk up to them like Snow White.
Talk about stuff, because they
is it like Snow White and the Seven Dwarfs where they just come?
Very much like that. When they come up and the birds sing to you and stuff. Not quite, okay, but
I'm just kidding.
Animals are much friendlier to the scientists than just say, because you don't see these animals walking around. This is Pasadena, right? They're in the city.
Yeah.
And so so they are, it's just really interesting about this. And the people who work there, they are, the way that they view the universe, the way they think about it, and how hard they're working on these things to explore our solar system and all the rest of it. It's really remarkable. So, if you got people that can figure out how to swing the Voyager spacecraft around using gravity assists around other planets to get around to other planets, and then to extend its life by years and years, to the point now, they are still getting signals back from the Voyager spacecraft, and they're in interstellar space.
Wow.
So what does that make us? What does that make us? Okay, we've got humans in space 24/7 on a space station. Okay. We send up appliances all over the solar system. We've got rovers, we've got orbiting camera systems, all the rest of the stuff. We got we got a couple of very nice, in fact, more than two very nice space telescopes out there. Most famous of which are the Hubble Space Telescope and J West. Okay. And of course, we got some billions of people here standing on the planet right now, but we're related to all of them. We're all connected. Okay. All right. So there's not like the astronauts, and they're somehow separate from those of us on the ground. We're all related, right? So we're not just Earthlings anymore, okay? Not really, if you want to be honest about it, okay? We are a spacefaring species.
Yeah.
And so our, if
do I have to change my title now?
Yes. To Paul Newton, spacefaring.
So
being.
it's Reverend Colonel Paul G. Newton.
Only in
Paul
space.
just got his Reverend status, so pretty soon he's gonna be able to marry people.
I'm also a colonel.
And a colonel. Okay,
yes.
We're gonna start calling you the colonel.
I'm Reverend Colonel Paul G. Newton. I went to auctioneer school when I was younger, so I'm actually a colonel.
You're actually auctioneers are colonels. That's gosh.
Yes.
I want you to say that, Paul.
Oh my goodness.
No,
I'm not a doctor. Jim Norwood said Dr. Paul Space Traveler.
There we go. That's right.
I'm not a doctor.
Dr. Paul Space Traveler.
Reverend Colonel.
I think somebody asked if we have ever made our own telescope. Yes. I have not. Scott, have you?
You have, Annie. You made the Galileo scope.
Oh, that's a kid. That's a kid I put it together. That's different.
Counts.
Okay, so there's different levels of making your own telescope. One of them is that you've designed a telescope, put it together, made it work. Okay, I would qualify that as making a telescope. All right. There are other guys who took, like John Dobson, for example. John Dobson took porthole glass from ships and beach sand, okay, and ground out a mirror and then polished it. Okay. That's how he made his telescope. That's not the invention of the Dobsonian, but he built Dobsonian telescopes, or he didn't call them Dobsonians. John Dobson didn't like calling those telescopes Dobsonians. Okay, he didn't attribute any of that to himself because he didn't invent the design. Okay, this is a Newtonian telescope. Isaac Newton mounted into a cannon mount. Okay, and his last name was Dobson, so they started calling him Dobsonians. He hated it. Okay. So maybe later on it kind of grew on him. But I remember getting a letter from the guy at one time when I was working at Mead Instruments, and he was telling me, please stop calling these telescopes Dobsonians, okay? I'm John Dobson, okay? And so anyhow, but
well, we can just name them after me.
Telescope making. That's real telescope making, when you're grinding your own glass, figuring your own mirrors. If you want to get really, really good, really say you made a telescope, make your own eyepiece too. Okay, make your own finder scope. So, but the process of making your own telescope is it's a lot of fun. I did it in making a special camera called a Slevet. It wasn't my design, but I built one of only 4 in the world that existed. So anyhow.
So Beatrice has started a conversation in the chat about if Mac Casses are better at viewing clusters, I'm just paraphrasing, than Newtonians. So she started this whole thing, and I don't know if you've read it. So
I'm reading it right now.
Is it more satisfying? Is that more satisfying
like
than
looking in there and going, that's satisfying?
Some things are. Well, that's the new thing.
What I'll tell you, what gives great satisfaction to a lot of people in looking at deep sky objects is how tiny do the stars look, how contrasty is the image, how black is the background, for example, and that has a lot to do with the F ratio of the telescope, whether it's Newtonian or Maxitov. Okay, most Maxitovs have a long focal length, like f12. Okay, and therefore the central obstruction is kind of small. All right, secondary mirror. So think about the light rays coming down, hitting the mirror. Okay, now they're going up a very long focal length till they get to that secondary mirror. And so to capture the whole width of light, that angle is now kind of thin. All right, so they don't need a very big one. Versus if it's a short focal length, now the light rays come down and they have to come all the way up to where they're going to come to focus to hit the secondary mirror. But it's now, this cone, you can see my arms, is wider. So the secondary has to be bigger, okay, to capture all the light. All right. So, and you want to capture all the light, because if you make a small secondary and you've got a short focal length lens, you're not capturing all the light of that mirror. All right. So that is, so when you go to a bigger central obstruction over the mirror, the contrast goes down. All right. So the sky doesn't look as jet black. Okay. And what's happening is that actually the airy disk of the star is, if you dissected the actual image, okay, the airy disk is defined by the diameter of the mirror, okay, and the C conditions for the night. So it makes a spot. Annie, I'll have to show you this sometime in the lab.
Yeah, you're gonna have to.
Okay.
Yeah.
And something called the diffraction rings. They look like they're little hula hoops of light going around the spot, the dot of the light there, and then that's the star. When you have a bigger central obstruction, more light, a greater percentage of the light is now going to the first diffraction ring. Okay. And there's other diffraction rings around it too. So more light's being put out. All right. This lowers the contrast. All right.
Oh.
In a refractor where there's no central obstruction, about, 84, 85% of the light is held in the airy disk. And just a little bit is going to the first diffraction ring. So the stars look tighter. Okay. The background looks darker. These kinds of things. So So that's the deal. So you could have a Mac that has a very small central obstruction. Okay. Gives a great, beautifully satisfying view of a globular star cluster. You go, that's amazing. Looks like a refractor. Then I get out my refractor and I show you, no, it's not as good. Okay. Because there's no central obstruction. But we have to start shoveling out the money, because real high-end refractors, we know we sell some. Okay. Yeah. They are expensive. They're hard to make. They take very special glass and all the rest of it. Okay.
Yeah.
Macs are easier to make. than a refractor is. They also have the advantage they're very short and squatty. You've seen them, okay?
Yeah.
But they have a secondary mirror, all right? And so it's not going to have as much contrast as a refractor does. Newtonians, most of the popular Newtonians made today, they're very wide field instruments, okay? And so they have big secondary obstructions. But back in the 50s, especially in the 50s, you saw very long focal length Newtonians, really long. Like you have to climb into a ladder to go look through a 12-inch Newtonian, okay? So I owned one at one point, and it was an F10 Newtonian telescope. Now, I will tell you that deep sky objects and planets and double stars and everything looked extremely satisfying in this telescope.
Is that the correct image?
Yeah, so there's kind of, this is a standard Cassegrain type of design, okay?
Yeah.
That's a Gregorian reflector. And so you can see that the, what's called the nodal point, you see with the kind of the crisscross of the light rays there, they're crisscrossed. They're hitting a, instead of a convex mirror, they're hitting a concave mirror. This is flipping the image around and then coming out to the back where the person's eye is. Gregorian telescopes actually show images right side up, okay, instead of upside down as we normally look through them. So they're Gregorian Cassegrain telescopes are really good for making them into spotting scopes. This is a Newtonian design, okay? Isaac Newton's design right here laid out. This has a mirror that's not a sphere. This is a parabola. So the way that they grind this mirror is they start as a sphere and then they start deepening the center. And what this does is it makes all the light rays focus all at the same time. Okay, this gets rid of spherical aberrations. Then we just have a flat mirror and the light comes off to the side. If this was a long focal length, you can see just from the light rays, the ray tracing here, that secondary could be very small, okay? And that would, you get a very tiny secondary, it starts to look like what a refractor looks like, okay? So that's the deal on that. So the satisfaction, Tarek, on these things really is, it all just depends, okay? What is it that you're after, Do you want real wide field views and the highest contrast? You're probably going to go after a refractor, okay?
Yeah.
There's the Cassegrain.
What's that?
I think this is the Cassegrain, right?
Yeah, we looked at a couple of Cassegrains. Okay, now this is a classical Cassegrain. Okay, we've got a primary mirror that's either spherical or parabola, or it could be a hyperbolic. Okay, and then we've got a secondary mirror, which could be a sphere, usually is a sphere. And but the advantage of the Cassegrain is that it made the telescope shorter. Okay, and that advantage meant that we didn't have to have as big of a mount to hold the telescope because it's not as big and as heavy. Yeah. So these are all little trade-offs of what you want, what. So they make most professional telescopes made today are Cassegrain designs because they can fold the light. Right. We don't see big refractors in space. No, we don't see those. Could you? Yes, you could. But
big old that you have to get on a ladder on space and
it's a little bit of a climb.
Gravity, you don't need the ladder. Okay, you just
that's
float up there.
Just float up there.
It's a little bit of a climb. That's all.
Just take your helmet off and look in the eyepiece for the nanosecond that you can do that. So,
speaking of gravity, let's talk about the dust that hit the James Webb Space Telescope. It was dust. So as we were talking earlier,
you're talking about the strike on the mirror, right? That everybody says.
Yeah, because we were talking today, and I said I heard a rock hit at the telescope, and so
smaller or
Yeah,
something, right?
yeah. And then you looked it up, and you said it was a tiny piece, and I said, okay, what's the difference between tiny in space versus tiny on Earth?
What do you mean
What
by
is
tiny?
there a difference? So then we
Right.
did some more digging, and we figured out it was dust that
Signs
actually,
of dust. Yeah.
yeah,
So,
that hit the
but you've got a
telescope.
piece of dust coming at you at 50,000 miles an hour or whatever it is. Okay, it's got a lot of momentum. Okay, boom.
It's not like the movies where they show the guy floating away slowly into space. That it's actually being propelled at a very fast pace. Is that what you're telling me?
Yeah. Well, even the astronaut, it depends, in relation to what, okay? But, some things are, we got something moving
Yeah.
100,000 miles an hour, then it looks like this
What-
50,000 miles an hour is very slow.
We use
Yeah.
we're starting to use rail guns, and they take a half inch by a quarter inch diameter, just a piece of metal. And they don't even no aerodynamics, no nothing. It's just like a cylinder. They shoot it out those things, the electric railgun, and what is it, Scott? Like 10,000 feet per second, something like that. It's crazy.
It's only 5,400 miles per hour, okay?
Oh.
Versus spacecraft, which travel much faster than that.
Yeah.
Okay.
So that one
And-
little piece of metal that pops out of that railgun can go all the way through any armor that we have.
Right, and that's
So
only 5,000
imagine
miles.
what a
Right.
piece of dust does at 17,000 miles an hour.
Miles per hour. Yeah. Yeah.
But
So
I
this is
don't.
why
I
we
don't.
have to clean up space, because we're flying
Well,
through
and I didn't-
space.
Get a
Well-
broom.
Yeah. Well, and I get to it, Reverend Paul. So
Reverend
I don't think.
Colonel.
Oh, I'm sorry,
Reverend
Reverend Colonel Paul.
Well,
I don't think we understand the reality of how fast that is. I mean, we've seen stuff go fast. Of course, we have race cars that go really fast and things like that. But I don't think that we actually understand the speed of that. And I'm kind of curious what it actually feels like.
well, what does
Like,
it feel
would
like
you-
right now?
Yeah,
I mean, you're there, you're sitting in your home. How does it feel?
we're spinning
I'm not
at
moving anywhere.
15,000
We're not
miles
moving,
an hour.
right? Yeah, but we're going
I know,
60,000 miles an hour.
60,000
We're going
miles an hour.
60,000 miles an hour around the sun
Yeah.
right now. I don't know.
And we're
You
spinning
feel
at what? How fast
Can
are
you
we
feel
going?
it? Scott, can you feel it? I know you can feel it there. I can't feel it
Well,
here.
I do. I feel a little dizzy. I do. I feel a little dizzy. Okay, so
Well, that's-
all right. So
Uh-huh.
think about this. Okay, you're going 60,000 miles an hour around the sun. Okay, the sun is in a spiral arm of the Milky Way galaxy. Okay, it's also spinning, by the way. All right, so that's about roughly. I mean, these are rough numbers. 500,000 miles per hour. Okay, the whole galaxy is moving. We're all moving. Okay. So, and only I'm giving in reference to the Andromeda galaxy because the Andromeda galaxy and the Milky Way galaxy are on a collision course. They're heading towards each other. All right. So that's relative speed towards Andromeda is about 1.5 million miles per hour. Okay. So we're flying to a new part of space that we've never been to before all the time.
So according to NASA, Webb's mirror was engineered to withstand bombardment from the micrometeoroid environment and its orbit around the sun. Earth L2 of dust-sized particles flying at extreme velocities. While the telescope was being built, engineers used a mixture of simulations and actual test impacts on mirror samples to get a clearer idea of how to fortify the observatory for operation in orbit. The most recent impact was larger than was modeled and beyond what the team could have tested on the ground, and it was just dust.
That's crazy.
It's crazy, isn't it?
It is very, very crazy. It makes me think about you talking about us spinning and stuff like that. Makes me think about all the times, like when you have an ear infection or something like that, and your equilibrium gets off, and then you're like, you feel like spinning. It's crazy how our bodies are made to be able to withstand the motion of the earth and what's going on with it. It's like you said, it's all intricate. We're all part of everything. And so it's just,
part of it.
It's interesting.
Right. So,
yep.
Yeah.
I do want to make a comment about Jim Norwood's AC.
Okay.
He said he didn't have time to make a telescope because he's putting an air conditioner in his car. I'm going to fix that issue for you really fast, Jim. It's called roll down the windows and stick your head out. There you go.
Now we do have a question.
All the time in the world.
Connor Bradley does have a question that says, with big enough telescopes, can neutron stars be seen visually in dark skies?
Well, that's a good question. Let me check something here. There's something called neutron stars.
Mm-hmm.
Yeah. So the short answer is yes. Okay. There is an object called the Ring Nebula. Okay, M57. And I have used, under really, really dark sky conditions, and I mean dark, okay, an 8-inch telescope and have seen this central star in M57, and that is a neutron star. It's a magnitude 15 or 16 star. And, you have to be good at observing faint deep sky objects. You have to use what's called averted vision. If you stare right at it, you don't see it. You let your eye wander away, you relax, and you can detect it. Okay. So, but certainly we have Dobsonian telescopes with, 12, 16, and 20 inches of diameter. That could, in the 16-inch and 20-inch range, it's easy. And then we have the Fulham folded Newtonians, which range from 30 inches to 65 inches of aperture. And it can absolutely see those things. No problem. So that's the deal. And this is, so Pekka, was that question naked eye or with telescope? He did say, maybe you're answering another question, but where it relates to neutron stars, they can be seen. Next question.
They're really chatting it up in the chat. It's really good.
If I stick my head out, I just get my sunburned head. That's right.
No, you're supposed to put sunscreen on. See, then the wind goes across and you've got the wet, greasy feel.
We gotta be a man.
It just adds.
Gotta be a man.
So when I was a kid, okay, our air conditioning in our car was called a 55x2. Okay, and that was, you roll down both windows and we was going 55 miles an hour.
That's right. That's right.
We didn't have an air conditioner in our car,
I grew up driving a 66 Chevy, so I know exactly how that is.
All right, there you go. That's right.
But air conditioning is nice, Jim. I have to agree.
Yes.
Hey, let's talk about
contributions of humanity's, compassion towards humanity is air conditioning and central heating.
Yeah. Yeah. Okay, let's go over events real fast. What's going on in Explore Alliance now that we've got off onto many topics of space.
Yes, that's right.
Squirrel.
That's okay. Mm-hmm. It's fun. It's fun when we chase squirrels. So we have the Arizona Dark Sky Party coming up in September, and then we also have the Nebraska Star Party that's going to be in August, I believe. Is that right, or July? I can't remember off the top of my head.
I think it's August is when it is. Let me just double check for you. Nebraska Star Party.
Sorry, I'm at home and I don't have my regular computer in front of me. That kind of puts me at a standstill.
It is end of July. July 24th.
End of July.
29th.
Okay.
Yeah, they changed the new moon, so that's the deal.
Okay. And then there was one other thing happening in September, but I can't remember what it was. It was another star party that's happening. But we have, we have a lot of things that are coming up pretty soon. We're going to be selling the things that you need to watch the eclipse that's going to be coming soon.
Oh, yeah,
and
right.
So we're going to be gearing up towards that.
These are our eclipse
Yep.
glasses. They just came in today. Okay.
Yep.
And
Yep. So
they'll be back up on the website. And
What,
so
Yeah.
for
How many did we get? Like half a
thousands of
million?
them. No, we didn't. Not yet. We will.
we might need.
This is the first production run, and so these are USA made, which is important because there were a lot of counterfeit type eclipse glasses made. So these also have a special watermark on them. Okay, so they're authenticated and they are ISO safety tested. All the rest of that stuff, everything that an eclipse glass should be, these are okay. And I think that you can get they're going to be sold, I think, minimum packs of 4. We learned our lesson last time during the 2017 eclipse when we offered to sell one eclipse glass at a time, and in one day we got 35,000 orders. 35,000 one day. You guys think about licking the stamp, placing one of these and dropping it into the envelope 35,000 times, and for one day, and that's just nuts. So we're going to be minimum order of 4. It'll be somewhere between $9 and $10 retail, but you'll be able to buy boxes of 1,000 if you want, or 5,000 if you want, depending on what's going on for your school or all the rest of it. But here's the main point: let me underline, do not wait until the last minute to buy your eclipse glasses, because that's what everybody does. That's what everybody does. And then they're all disappointed and angry because you can't fulfill them fast enough for them. Okay.
And it ends up being a catastrophe.
Yes, that's right.
Everybody's sad. Everybody's sad in the situation. So
Explore Scientific delivered millions of them in 2017
oh my gosh.
For the total eclipse there. But there were, at the very desperate end, okay, it did get a little ugly. So in private, I'll tell you some of the stories.
When I started here, it was like,
what they said, but it was crazy.
I know. Well, it was great.
We're sorry.
When I started here,
we apologized over and over and over and over again, but anyhow.
Well, I'm sure it'll go a lot smoother this time. You live and you learn from the first event, and then you go on, you fix the next one.
So Harold Block, he says, I'm putting the 8-inch newt on the SW-EQ6 because the nights are somewhat nicer and will have that scope chained to the mount and pier. Not quite sure what that means, but okay.
We're down with that. And I see that Pekka is saying, Scott, make sunglasses that have a small notebook on the handle so you can notice your eclipses seen with those glasses. Pekka, you're going to have to draw that out for me on a napkin or something. Harold Locke says, Mom's done at the dentist. You fine people have a great night. Tell your mom, have a great night. So from us.
We went away. Okay, so it's getting nighttime. Actually, the sun doesn't go down here until almost 9 o'clock. It's pretty nice. The other thing that's going on is we still have that. Nobody has utilized the 20% off the Arizona Dark Sky tickets. So if you're a platinum member,
Yeah.
I would highly recommend utilizing that if you want to go to the Arizona Dark Sky Party. Utilizing that 20% off. It's not going to be going very much longer. So
How did they do it?
They need to
How do you-
email me at they need to email me at Explore Alliance. Explore Alliance at explorescientific.com. Sorry, went out the door. And I'll get you a code, or I can set up your order with a discount. So that's not something that we're just going to put on the website, because you have to be a platinum member to do that. So and then the other last thing that we have is we have a pair of binoculars. The SKU on them is 616. I can't remember the specs on them, but we have $100 off for if you're a platinum member, if that's something that you want to utilize as well. I think they're like a $600 or $700 pair of binos. They're Alpen brand.
What brand are they?
Great.
They're Alpen?
There's Alpen Apex 8x56 binoculars.
Ooh.
So
Retail
great for
of $499.99.
So 500. I was quite a bit off, but anyways, so utilize that $100 and get you a pair of great, amazing binoculars to be able to do some nighttime viewing.
Those are ED glass too. Yeah, these would be fantastic.
They're really
for
good.
Astronomy. Get yourself a zero gravity chair, and so here, I'll put the link in here for that.
Yep. So
Excellent.
And then if you have any questions about what benefits come with the with your membership, just email me and I'll be more than happy to answer those questions for you. There's some great opportunities being a part of the Explore Alliance, not just as a member, but as an ambassador or as an affiliate. We want to share your story. We're not just a company that's about just showcasing what the products we have. We want to share your story. And so we would love to partner with you and be able to do that. So if you're part of an education group, or if you have any type of educational outreach or anything like that, please email me, and I would love to talk with you and get you set up with that. So, but yeah, other than that, it's pretty much, we have our pretty much the same shows every day. We don't have On the Wing anymore. This show will be in replace of that. We have the new Eclipse show that's on Tuesdays. Of course, Daniel Barth, How Do You Know, is on Mondays. Kent with First Light Chronicles is on Wednesday, and then Friday is a Focus on Astrophotography with Tyler. So join us. We have a lot of things going on here at Explore Scientific. We have a lot of shows happening. On the Wing has kind of moved to our Amazon live feed that happens during the day. So
yeah, today we talked about the Claypool Reservoir in the 50s with the giant, all the millions of ducks on live TV.
Oh,
wow. It was really cool.
That is really cool. So, but we have a pre-show that starts at 1:30. It happens every single day. It starts at 1:30. Sometimes we're a little late, because time and people and things. Anyways, 1:30 is supposed to start at 1:30 every day.
Time and people and things.
Anyways.
Yeah.
So 1:30. So that starts at 1:30, and then we move on over to Amazon Live. But you can still see us on YouTube and things like that. Those shows happen, and so we are here more than once a day, 2 to 3 times. So hop on, join us. We would love to see you. Please give us a shout out during those shows. We will, whoever's on will engage with you. So and if you want to watch a crazy show, come watch Lucy and I on Tuesdays, because we like to tear things up.
You guys are funny.
You set the place on fire once.
So
what did you?
So you set the place on fire once.
Huh?
Yes.
You guys made fire in the studio?
It was Tyler's fault. Yeah.
Tyler made a product smoke.
Okay.
Yes, we were building a stem. We were building a one of those. I can't remember if it was the 145 stem thing with the electronics, and we couldn't get it to work. And I went and got Tyler, and Tyler came in, and all of a sudden he starts taking the batteries out, and smoke comes up. It's because Tyler came in.
I was not here that day. That was the day that I had to go to Dallas. So you can't blame me.
I want to point out that we did not break the product, because the following Tuesday we used the exact same thing, and Kent helped me put it together, and it worked just like that.
Okay, so it's probably the batteries that were smoking, right?
Yes, it was the batteries.
So Jim Norwood's actually saying, here's some electronic wisdom here. Once you let the smoke out, it's very hard to get it all back in, and that's what makes electronics work, is the circulation of smoke.
Yeah.
That's what Tyler kept saying.
Probably not the real reason, but
That's what Tyler kept saying, and then I was like, watch me, I'm going to make this thing work.
So Beatrice Hines had a good question here. She wanted to know, how long can you store eclipse glasses? Can you store them for a couple of years? The answer is yes. Okay, it is yes. Okay, you can store them. And I've used eclipse glasses that are old. Okay, but if you see any degradation at all, any scratches, any thinning of the coating material itself, let me just put it this way: eclipse glasses are so inexpensive.
Yeah.
That it's worth getting a fresh pair. Okay, if you have any question at all. Okay, because your eyesight is invaluable, right? So you just don't want to risk it if that's the case.
You can give them
but if
to
you know
your.
What you're doing, you
can give them to your nosy neighbor. No? Okay, don't do that.
Oh, they throw people in prison for stuff like that.
Was it on purpose? They knew the sun was hot.
But he's a reverend colonel. He won't get thrown in prison.
Reverend Colonel Paul G. Newton.
Okay, so I really love.
I'm totally fired now.
You're fired now, Paul. Yeah. Yes.
Scott, I really liked that video you made the other day about why you should not. I don't know if it was the other day, but anyways, I watched the video.
That is an old video. That was 2017. So here's the background story to this. Yeah, you weren't here at that time, but we get a one of the new customer service people comes running up to me and says, "Hey Scott, there's an amateur astronomer who owns one of our refractors." Okay, now. You own one of our refractors. I'm assuming that you know some stuff about astronomy, but that's an assumption, okay? And so they wanted to know: is it okay to use eclipse glasses to look through the telescope? Okay, and the answer is absolutely not. Absolutely not. So I just dropped everything I'm doing right then, because I'm going, oh my God, if this guy's thinking this, how many other people are thinking about this? Okay. Can I use eclipse glasses to look through my telescope or through my binoculars? Okay. So I took a pair of eclipse glasses out. I took an over the lens solar filter. Okay. And I was showing them how to apply that over the telescope. And that's how you should do it. Versus taking a pair of eclipse glasses, putting those puppies on and looking through the eyepiece. All right. So I just held the eclipse glasses over where the eyepiece was, and it, like a laser beam, just blew a hole right through, instantly through the eclipse glasses. Okay.
Yeah.
And that would have been your eye, just like cooking. Okay. In the eyepiece. So absolutely don't do that.
But I liked your technique that you used in showing that and that would be a great way to check something, is you pointed the telescope at the sun and you put the product in front of the eyepiece, whereas putting it on your face and looking, so I thought that was really,
I would have boiled my eyeball out. So
yeah, but I know that, but I'm saying that somebody who's not for sure, like that astronomer that called customer service asking, well, why don't you just I mean,
why don't you give it a try and call us back? No, we did not.
no,
do
no, no,
that.
no, no.
Okay.
I'm saying
We're
not
here
on
to
your
protect.
face. At least put it
We're here to serve and protect.
serve
Well,
and protect.
At least sell.
Yeah. Hey, I wanna.
I'm teasing.
Beatrice is a little upset that we don't have On the Wing anymore, but I do want to let Beatrice know that it is still here. It happens at 1:30 on Thursdays and runs over into the Amazon Live show. So it goes to about 1:30 to almost about 3 o'clock. So yeah.
Beatrice,
So
just
y'all
could
can,
not, the reason why we did that is our sales season is picking up, and COVID is now tapering off. And so we're not in the office as much as we were before. Okay. We actually have to get out and visit people and do these kinds of things. And as far as our sales function, this is what lets us actually do these shows, is that we're actually underwriting that with Explore Scientific. So, but we as Annie said, yeah, we still have the show. It's just combined,
Yeah.
right before we do Amazon Live. Is that right?
No, we
Is it
basically
during
do
Amazon Live?
Amazon Live as
Okay.
On the Wing.
Yeah.
so
that's
so
good.
the way
You'll
the
learn more
shows
about
work.
product and
Yeah.
also the bird that you're.
Yeah,
we're
yeah, it's really good setup. Like today, they were going over what Paul was talking about, but we'll do the 1:30 show and then stop for about just a few minutes, not even 5, and then hop
Yeah.
on over to Amazon Live and continue the show. So, but he does implement a lot of that information that he had on the Wing. So
Today
it's really
we were
good.
talking about
Really good.
Ricky Martin. No, a purple Martin. That's right. A purple Martin.
How did you get Ricky Martin out of a purple Martin?
He's just. He's just throwing it out there, and
He's winging it for On the Wing.
he's winging it for On the Wing. That's right.
Oh, that's my only dad joke for today.
All right.
No,
But yeah,
Kent was talking about the purple Martins, and he said, "Go to the next picture." So I went to the next picture, and it was Ricky Martin. He's like, "What?"
It was Ricky Martin. Yeah, that's right. Poor Ricky. Hey, man, if you're watching this show, we're sorry. So,
I'm not sorry.
that's right. All right.
I don't think Paul's ever sorry.
Anyhow,
Sometimes.
I hope you guys are staying cool out there. It is hot here in Arkansas. We're triple digits right now, 100 degrees. I think it's supposed to be
A cold front's
101.
coming in.
Yeah, it's going to be 92.
A cold front's coming in next week.
Really? You look scared.
Yeah, I'm
I was-
excited.
She does look scared, actually.
That's my scare. Oh, I would hate for you to see my actual scared face.
Yeah. So do you have an Explore Scientific weather station in your home now, Annie? Not yet.
I plead the fifth.
Annie? You didn't install one.
No, I need to have. I need to install one. So I really need to install one because we get a lot of questions about them, and so they're amazing. We have one in the store, and we have a sensor on the roof, and so in the middle of the remodel, we had to find a place for it. So we've got it all set up again, and so it just hooked right up, and it's telling us that it's sweating buckets kind of heat outside.
Sweating buckets.
Is that the actual term that's on the screen?
Yes, that's what it tells you.
That we invented here in Arizona.
Yeah.
We should.
Right.
You should start doing the emojis like, okay, this is a little bit of sweat, and then it's like I'm really hot, and then I'm like, I'm dying.
Pekka says he's
Yeah.
wearing fur hats in Stockholm.
I
What?
don't believe that at all. That's not true. That's
It might
not
be
true.
It might be true.
No, it is not
You're pretty
true.
far
It
up
is
north there.
no, it
Stockholm,
is hot
Sweden.
there.
Sweden's
No,
not
it's hot
that far
there.
north.
Let's see.
I'm
We'll
telling-
check the weather right now.
Calling your bluff, calling your bluff, Pekka. Calling your bluff.
It is hot. It is hot there. I know it's hot there.
Scott's gonna call your bluff.
Let's see. It is kind of chilly. It's 56 degrees Fahrenheit.
Nice.
So
Yeah,
now some people think that
but they
13
but
degrees
they
Celsius.
Not getting a
13.
tan
They-
today.
Yeah.
yes,
So
but
if it had been warm, yeah, you might be putting on a fur hat. That's possibly true. They are experiencing high humidity, wind only 2 kilometers an hour, precipitation chance only 3%. So that's your Stockholm weather for the day.
that's your Stockholm weather for the day. Yes,
That's
but their temperatures are probably different than ours too. So, yeah.
It's got to be terrible in Finland. Finland's
The
even
same
more
planet.
north.
And, yeah,
we
you
have
know,
we have moved to the weather section of this show.
Yeah, that's right. The weather segment. Yeah, that's right. I need like a green screen with the wind and stuff blowing.
So my dad had a Weatherstone.
A Weatherstone.
Yeah.
Paul,
If it's wet, it's raining. If it's dry, it's hot. If it's cold,
it's
it's
burning your hand.
winter.
It's hot outside. I see.
If it's
All
rolling,
right.
it's a hurricane.
On his balcony, so that's getting chilly. It is. You're right. And Pekka says he's already photographed the first quarter moon today.
Nice.
If you guys did not know this, Pekka is quite a lunar photographer. He did. I mean, he had that beautiful image that got shown all over town, and so it's awesome. Keep it up. Keep up the good work, Pekka. Anyhow, do we have anything more to add before we close?
Before we move on to something else crazier? No.
Before we get to the crazy part of the show?
Just leave it to me.
I'm so glad that we laugh on here.
And the Ron Burgundy Weather Hour. Yeah.
That would only be if I had a camera. If there was a camera on me, it would definitely be the Ron Burgundy.
I'm so glad, but I really am so glad that we can get on here and just laugh and have fun and talk about serious things like telescopes and then move into after hours. So it's good.
Right. That's right. We hope we answered your questions about intelligent life throughout the universe.
So tomorrow is Tyler's Focus on Astrophotography. Make sure you join him at 4:00. I don't know what his show is going to be about, but I'm sure he'll have something good for you. So, yeah.
He is wrangling guests as we speak.
Okay. Having guests is important. People want to see new people. That's for sure. So, thank you, everyone. We will be back tomorrow, and then if you don't catch us tomorrow, then we'll see you next week. On the 12th of July, we will have the 99th Global Star Party. So it's coming back. And then on the 16th, we will have our 100th Global Star Party, which is our major milestone. So
yeah, it's exciting.
Right.
It's exciting.
And Connor Bradley wants to know, have you built a telescope from scratch? We touched on that a little bit, Connor. Okay. So what is by scratch? Okay. So are we talking about polishing your own mirror? Or are we talking about taking a pickaxe and mining the material to build your own telescope? So there's a level of building your own telescope where you buy finished mirrors, for example, and you lay out your design and you build it. That's very rewarding. There are other people, though, that do get into it and polish their own optics. You can still buy glass blanks and the polishing compounds and all the rest of it. So it's a lot of fun. Connor, my question to you is, have you done it? So, and I think that maybe you have. So anyhow, that's all I got. That's all I have for right now. You guys keep looking up. Yep. And thanks for watching. Take care.
Bye.